Welcome to Fraction of a Teacher, the podcast where two trainee maths teachers navigate the wild world of teaching, equations, and everything in between. I'm Francis.
And I'm Jen. Join us as we reflect, share stories, and have a laugh about life in the classroom. Whether you're thinking about starting a career in education, a trainee teacher in the thick of it all, or just curious about what it takes to shape young minds, you're in the right place. So let's dive in.
Hey, welcome back, guys. It's Francis and
Jen, hi everyone.
hi. And we had a starter planned, but I want to just quickly say, Jen, what's the exciting news?
My exciting news is that I was offered a job today. So if I sound a bit tired, folks, bear with. I've had an interview all day today, but it's fantastic news. It's a great school, and I've been offered the role to start in July.
The last few days, I know you've been absolutely flat out preparing for, and it feels like it is just the right fit. So I'm so pleased that you are there.
I'll be honest, mate, it's really weird because since our last podcast during half term, it's all happened. So it was on the Thursday I applied and got the interview. No, I do apologize. The Friday I applied and got the interview for the following Tuesday. But yeah, it's all been very quick. And then obviously went today, had a student tour, had to teach a lesson on compound shapes, and then had the interview with the deputy head teacher and the head of maths, and then ended with being offered a job, which I graciously accepted.
That is awesome. Did our podcast on preparing for interviews help you?
I was asked a question to describe myself in 6 words. Guess what was the first 3 words?
You said in the first 3 words, and then did you say, I'm sorry, I don't have 3 more because my podcast co-host and I only did 3 of these?
I did not say that. I was very flexible and adaptable to think of the fact that I'm also very ambitious, hardworking, and extremely positive. So I used the other 3 words that I had just sitting in the back of my head ready to go.
That's awesome. So the moral of the story is don't do what we did in the previous podcast and just prepare 3 words, prepare at least 6.
5, 6. I wasn't expecting 6, but it's a good thing I can think on my feet.
Well done. That is super news. Fun as we start moving towards those jobs and like tell people what it's actually like to move on. Now on job lined up after the summer. Well done.
Even before the summer. So we finished the very beginning of July, and the Monday, I'm in a job. It's that quick for me.
You're going to take the weekend off, yeah?
I am going to take the weekend off. I just thought going in and getting all the systems, having come from America from such a young age, I kind of know how important transitions are for me. I want to do this right. I don't just want to be the new girl in September. It was really important for me to get into a school beforehand, get to know the systems, get to know the kids, start making it my home. So I was pushing for July.
Definitely. I can see real attractions. If you were going to job at one of your placement schools, particularly if it was a second placement, just that kind of smooth transition, already knowing systems and things. Both of us are facing that new kind of steep learning curve, but yeah, we're going to really have to hit the ground running, I think, in September when we're like the live real teacher and
I know.
like not just the student. So yeah, I think anything we can do to get ready for that. You're right.
I mean, and we're gonna have a forum group and everything. We're being let loose with students. This is amazing.
It's this year. Like,
I know.
It's not that far away.
On that note, should we start with our starter?
So the actual starter, I'll let you introduce it.
Okay, so this week we're going to be talking about our favorite GCSE math topics and really about finding the fun in GCSE maths. We've talked a lot about being a teacher and obviously being a trainee teacher, but we actually haven't talked about anything really specifically math related in terms of a whole session. So we thought we'd talk a little bit about our favorite math topic. So our start for today is a nice simple question. I say it might not be simple with us, but we're hoping it's a simple question. What was your favorite math topic as a student? And then obviously now as a teacher, is it different? I'm happy to go first. So my favorite topic as a student was algebra. I could not do enough of algebra. I loved solving the equation, and the more complex to me, the better. So if it had a quadratic in it, simultaneous equations, all of that, I really enjoyed. And then graphing it afterwards and seeing what it looked like. That exploration was just my favorite. And it lends itself nicely to statistics, which is about trying to make sense of numbers and data. And obviously, within my job, I was doing, I don't know if he knows about me, I was administering IQ testing. I was using those numbers to help somebody understand how much they could comprehend information, how they would approach a problem, which was really interesting. It naturally lends itself to my area of what I loved doing.
That is handy. The funny thing about algebra is, I think it's definitely something where kids sometimes say, "What's the point in this?" It can feel really abstract. The reality is that it underpins so much, and is actually just beneath the surface in so many things. It just across maths, but across all kinds of science, technology, engineering, and
Mhm.
it feels like it's the backbone for almost everything else.
Yeah.
Wow. Okay, so you loved maths, you loved algebra
Yeah.
at school, but is it still a favorite? Or are we
No.
going to do that
I
later
mean,
on?
it's not my favorite topic to do now because I can see kids really struggle with it. And you say the word algebra and the fear just
Yep.
their face. And I'm still yet to figure out how to kind of address that. And we'll learn as we go through. My favorite topic now to teach is geometry because every shape has triangles in it. And if you start with the magic triangle, you can really get them to explore different shapes and help them understand angles and polygons. Then you're talking about GCSE questions and trigonometry. You know, it goes across everything. This might be coming up because I literally had a compound shapes lesson today, and I feel like I really enjoyed that. And there's some good news that came from that. So I might be slightly biased towards recent events. However, I have always loved that because you can use manipulatives and the kids can really start grasping that concept. And you can get them to make shapes like soccer balls. They can understand when a 2D shape then becomes a 3D shape and tessellations. That to me is a really fun math because I think there's a lot of enrichment that can go along with it.
I think you're right. You see, you've got the manipulatives, the visual representation, and you can have some cool posters on your wall
Yeah.
when you're a maths, we're proper maths teachers, and we get our own rooms.
Or
So,
maybe we should do a podcast on how we're going to decorate our rooms.
oh, that is something I have thought about a lot. I'm so excited about the idea of
Oh,
not moving rooms every lesson.
tell me
That
about
is okay. That's up on the list
it.
now. That is a really good idea because that's something I've been probably thinking about too much. Really getting a bit ahead of myself. But yeah, that's the future. I think we should also make sure we think a little bit about why. And there's probably research to this too. There is definitely variety. I've seen classrooms with really clean spaces. Does that allow students to focus on the teaching? Yeah, really busy ones. Stop.
We're going to come back to this topic. We will come back to how we're going to decorate our rooms and the science behind it. Okay, so that's mine. What about you?
At school, into sort of higher level maths, I always felt happy whenever there was anything to do with mechanics. As soon as it involved something I could visualize in my mind and then apply maths to, particularly forces and movements and moments. So that just, for me, I don't want to say it was easy. It was just a lot more logical than some of the more abstract kind of pure maths. And I think, therefore, mechanics was probably what was critical in underpinning my desire to do and study engineering at university and to do mechanical
Hmm.
engineering. I think there was a real sort of logic to that. And yeah, it was the satisfaction of being able to model something, having a real world representation and then understand something about it. And I suppose that ultimately mechanics pretty much underpinned half my degree. So
Yeah.
I'd say that that really was enjoyable and satisfying. And sometimes it's tricky because sometimes you didn't feel you had all the information, but it was a way around to work it out. I'll be honest, it's a long time since I've really looked at that kind of higher level mechanics or above. It wouldn't be my favorite right now. I feel I'm not fully ready on that level of depth in the mechanics area. So that's that. But now to teach, the bit I really didn't particularly get excited about at school was statistics. It always just seemed a bit sort of dull. You had a few ways of looking at data which all seemed either a bit obvious or not particularly useful. I didn't do the sort of statistics elements at A level at the school I was at. You could choose mechanics or statistics. And I think through my career in the Navy, looking at data and increasingly bigger and bigger data, began to realize the power that was there. And I think in teaching statistics with the GCSE class at my last school, I really enjoyed getting back to the real world relationships, being able to bring in actual data and hand to the
Hmm.
kids and get them to tell me something useful from that. And that I really enjoyed. And I think finding something that's real, that's usable, you can actually work with real world questions, problems. You can then relate it to anything, whether it's politics, economics, or climate change. It was really fun to get people thinking about topics with broader application beyond maths. So actually, I think statistics is my new favourite, having been a bit of a least favourite. That's the turnaround for me.
What a turnaround.
Well, yeah, you never be told like 17-year-old me, but the more you look at it, the more you realise that statistics really underpins so much. I just feel like it was undervalued in my mind.
Yeah, I agree with that. As you said last podcast, how much you realize everything's interlinked. Do you think that lends itself to what you're saying now? That you feel like because you're seeing its value so much more, having looked at the GCSE curriculum with a teacher lens, that you're understanding its value?
I think there's an element of that. I've got a brilliant map of the different areas of mathematics. As I get further and further into trying to identify those links, it's kind of used to come back to. And yet, I suppose those links are absolutely everywhere. And particularly through algebra, as you've mentioned, I feel like I'm still at the early stage of discovering all those links and being able to really kind of share that with pupils. But yeah, it's definitely there. And I think that's only going to grow as we build experience. But I think my interest in mechanics comes back to the application. I feel like I'm a bit of a realist when it comes to maths. I suppose it's the applied mathematics side that I sort of come at this from, and therefore perhaps I lean towards that. But noting it's got to be underpinned by a whole lot of much more abstract maths.
Okay. May I ask a question?
Go on.
Thinking about statistics now, so you're going to have a young Francis in your classroom. How are you going to make statistics fun and applicable for young Francis?
So I think it's about using real world data where possible. Tables that you get in some sort of maths questions, which ask you to review a slightly dull set of data in a table, which is all very sort of removed from the real world, or just an oversimplification, or something that you're just not that interested in, whether, what proportion of the class blue eyes. I think there's just so much you can do to bring real world data in. There's a website I found when I was teaching about statistics to year 10, which was, I think it's called Our World in Data. And that was awesome because I suddenly found a source of data from across almost any topic you can imagine. And I was able to use those a lot in the kind of do now activities where I bring these in and ask the students to interpret that and tell me something useful and usable and relevant from that data. So I think for me, there's that. And I think you could then tune in even to think about the individuals in your class. What are they interested in? If we did a bit of an exercise in one of the classes where I gave them data and asked them to explain it to others in the class, working groups, I got the Premier League table with all the data that's in the Premier League table.
Love that.
And I gave it to a group. I thought, this is going to be great. They're going to love this. I went over and said, how are you getting on? You've got the Premier League table here. And they said, well, none of us really follow football, sir, so we haven't got a clue what this is. I made the silly assumption that the boys would be into football. But yeah, so I think finding what interests your pupils, and it'd be really fun if you got a feel for, if it's pupils you knew well, to be able to go away and find something that you knew was going to really spark their interest. So I think that for me, helping break down barriers so that pupils achieve early success and momentum in a topic and then have the confidence to move forward. I think that's where it is for me.
Love that.
At school, did you have anything that you didn't particularly enjoy within maths?
Trigonometry. I never got it in my head. I didn't understand the sine, cos, and tan rule. And then they show you the waves, and I'm just like, no.
So, talking of kind of abstract things, have you ever seen the explanation of that where you have a triangle within a circle? I'll find a picture for the website. But effectively explaining where sine, cos, and tan come from. It wasn't until
No.
suddenly I thought, why didn't anyone show me this? Why was it presented as these three random words which didn't really understand where those graphs came from or the background to it at all?
I would very much say that if I had had a teacher who would be making it more applicable to me, I would have loved it so much more. Something that I feel like I was missing was how it connected to each other. I just don't feel like I understood that relationship. It felt like three different things I had to just know and learn, and I didn't see that its relevance. As soon as I see its relevance now as a teacher, I'm like, wow, mind blowing how easy that is to remember.
Yeah, it's easy now. And I think it's then working out how do you then help 15-year-old Jen work it through.
Genuinely. That's how I feel. They might have done, but I guess they didn't explain it to me as a 15-year-old would understand. And I think that's the big difference for me. It's not that they didn't do a good job teaching. I didn't understand. And, I've said I'm dyslexic. There might have been something about the terminology and understanding the language that they were using, but it felt like it could have been more accessible.
Yeah, and I suppose particularly for us coming into this later in life with it being that much longer since we were at school, it's trying to get yourself into how do I make this engaging and interesting for somebody who's quite a bit younger, having not got that recent memory of being at school, and the world's moved on. Things are different now.
Exactly. I feel like now, having taught it in placement A, I can see the misconceptions I had about it. And that makes it really helpful for me as a teacher to understand what 50-year-old me did wrong. But there's always that worry in the back of my head that, am I that same teacher who needs to make it accessible but can't? So it's a balancing act without going down the rabbit hole of I've got this imposter syndrome. However, it's a work in progress, and I am on month 5 of being a teacher.
Yeah, it is early days. I think there's probably a slight benefit in not understanding maths really easily. Having had to work hard to understand elements of the maths curriculum, I think it's beneficial as a teacher because I think it might be very tricky if you're extremely competent at maths, and you always sort of have been, actually to understand where those misconceptions are and how it might help us slightly unpick how to address this. So I think almost there it is a bit of a blessing not being so good at maths, much to the point I wish I was better at it.
So what we're saying is we're always going to be math teachers.
Yeah, we're always going to be maths learners. Would you ever admit to your class that a topic wasn't really your favorite topic?
I did.
Okay, okay, go on. And how did that work?
So I was about to start teaching trigonometry, and I was really candid with my class and just said, as a 15-year-old, when I first came here and someone tried to teach me trigonometry, I struggled. I struggled because I didn't understand. And so I pitched it to a way of, I would like you to bear with me. On round 1 of this, you may not understand where I'm getting at. But if you work hard and we work together, I will do my absolute utmost to help you understand why this is applicable and how to understand this.
I love it. That's impressive honesty as well, because a lot of people wouldn't feel comfortable sharing that. That's impressive.
Thank
And do
you.
you think that helped them kind of buy into it?
Yeah, I mean, they got Sokotoa, they understood where we were going. I used a lot of real world examples. Unlike your class, a lot of them played soccer/football. So we bonded over using it to measure a football pitch. And I actually challenged one of them, saying, I can work out the hypotenuse of this pitch quicker than you can run it. And so we made a challenge to do that.
Did you go out and do that?
We didn't need to because I had already written it up on the board, so it didn't work out that way. But it was challenge accepted, if that makes sense. And I said, I will get to a point where you can work it out quicker than you can run it.
I love that. That's why I think you're going to be so awesome at this. Just
Stop
coming up
it.
with imaginative challenges.
Well, I mean, look, we do the best we can. And I know what 50-year-old me would say, relate to something that I'm interested in. To introduce trigonometry, I had them measuring the classroom. They were measuring the length of my classroom, the door, the tables, the computer screens, the whiteboard, my desk. They were measuring everything. And I had like 7 tape measures on the go. And I had yardsticks or meter sticks you have in this country, don't you? Meter sticks.
With the metric.
Gotta go with the metric, yeah. So I was using all of that to make it realistic about, well, if you want more accurate dimensions, measure 2 lengths and I'll give you the third. And so a squared plus b squared equals c squared. Well, that was a dream.
I love that. But I think there's something cool about that as well. And that links to my statistics. I remember getting the year 10 class to measure each other's height and check shoe sizes and first letter of everyone's surname. So they gave us our different types of data to kick off. And then we kept using that data again later on in the topic, and it was really fun because that was the data they by measuring each other's heights. I think there's something quite fun about relating it to the real world. Actually, if it's something you've actually got that real feel for what a meter is and how that hypotenuse looks and how tall someone really is. Because we then checked some real world statistics for the professional basketball players in the US and checked out their average height. That's insane. I mean,
Yeah.
but it was really fun, like looking at the tallest person in our class, right? How does that compare to the shortest person in the NBA? It was a really fun, random example to throw in. I think one of my challenges was just time and capacity. And you're amazing at going and finding all these ideas. And I suppose that's the bit I'd love to get better at, is being able to sort of generate this stuff, but more efficiently generate these kind of ideas.
I'll be honest, buddy, you would not like to live in my head. The amount of ideas that fly around there. But I kind of live by, so my favorite quotist is Alan Watts, and he was a philosopher. He started out as a school guidance counselor. A lot of people will know his voice. One of my favorite quotes of his is, "This is the real secret of life, to be completely engaged with what you are doing in the here and now. And instead of calling it work, realize that it is play." When I walk into a classroom, I want that exploratory aspect of my classroom. I want my kids asking questions, trying to find out how this all links together. I had a question today in my class, is it not cubed instead of squared when we were finding the area of a shape? And I was like, no, well, why would you think it's cubed? We explored that. It is play. It is learning, but learning through experience is crucial because that's what sticks. We talk about retention, and retaining is important to attaining. If you explore a topic and let them question it, like with interesting data, they're going to be like, what about this?
I was once observing a lesson about volume, and I wasn't really feeling that engaged. I was thinking, how would I go about teaching volume? And I thought, what if you could do a big question lesson where you start off the lesson with a big question? I thought, what would I do? I would do, can we turn the classroom into a swimming pool? Start thinking like, okay, so we're going to have a pool in here, and just get people envisaging the room full of water. Okay, what's it going to take? How would we work out how much water we needed? All of the water. I feel like the thing I really want to try in this school placement is a kind of big question lesson. I saw some confusion between area and perimeter, and actually, to walk around the perimeter and then to measure the area. Maybe there's something you could give that would really help people visualize it. So that's aspirational. That's something I'd love to be able to do, that sort of thing, which is the kind of stuff I think you're doing.
But you're thinking about the thing, and that's half the battle. Half the battle is just thinking about something that's a little bit creative out there and then going, how will this play out? Now, you say I'm better at it. I might just be a bit more gung ho about it rather than clever about it.
Gung ho wasn't one of your 6 words for the interview then?
No, no. Ambitious was one of them, and
Ambitious,
creative.
hardworking, creative. This is you.
Don't dampen my creative spirit. I'm an artist at heart.
I wouldn't dare. Awesome. Now, I think we did sort of have an aspiration. I think I've got one other thing I was going to mention, but is there anything else you want to mention before we begin to close down towards the plenary? Anything else you're thinking about in terms of this fun in teaching maths and how we do that?
No, I feel like I approach every topic with a grand idea or something I could do to make it really realistic.
How to do that for algebra yet? Because we're talking about some of the pupils finding it challenging.
Yeah, a lot of one-step and two-step equations, which I feel like personally doesn't lend itself to a lot of real life situations. Come back to me in a few weeks or months, and I might have something else. I just think algebra, once you understand it and have that aha moment, you get it and you love it because it's finding an answer and it's a process you follow.
Yeah, and I think for me, it's probably about getting the progression through the topic right, so that you keep people stretched just the right amount, not pushing them too hard so that they get demotivated, but not making it too easy. And I think that's tricky to do with a big class. Part of the motivation in algebra comes from solving. That's where success will breed success. Getting people at the right level is critical.
Yeah.
I think you fairly quickly move beyond being able to 2 apples plus 3 bananas.
I think the first step I always do with algebra is a lesson on how to substitute. Because I think sometimes we assume kids know how to substitute because of science and other topics. But actually, when you really break it down, if you give them A, F equals and C equals and give them an equation, can they work that out? Can they substitute in? Because if they can understand that, they can understand that the letter is representing a number or more than one number. And I feel like that lends itself really well.
Making sure the foundations are solid before you move on to...
Yeah. Scaffolding is really important for algebra.
I agree. Get the basics right.
Yeah.
Awesome. And I think the only other bit I was going to mention was what we did last year and put into practice in our first placement, financial maths. I think it was fun how much put a pound or a dollar sign in front of something, and particularly if you can then relate it to the real world and the context that the kids are familiar with. It felt like a great way of engaging people. So yeah, that's the one that I need to look at more broadly than, say, statistics and percentages. Where else could that financial maths be applied to make it fun, interesting, and relevant?
Absolutely. That's a work in progress.
Awesome.
So we have a plenary. Thinking about topics, we talked a lot about what we love to teach. What topic are we working on developing our love for? To put a positive spin on it. I feel like that's how we're going to go.
I love the way you put a positive spin.
Well, one of my 6 qualities is being positive, so I'm living up to my expectations here.
I've got 2 in my mind. I'm going to be unhelpful here and say it's that connections between part that I feel is my real focus at the minute. Give an example of that. I feel like it's something that I was working on last term was factorizing and expanding quadratics. That was something that I felt I needed to be much slicker at and just make sure I was really solid on so I could confidently teach it for students. To spend a bit of time focused on that. When I was at school, or perhaps my memory is just really awful, I didn't think of factorizing and expanding as effectively inverse operations. I didn't really spot the link. Actually, I'm a massive fan of the grid method for both factorizing and expanding. I think there was a link there that I really hadn't spotted. And it suddenly clarified in my mind when I started thinking about it in order to teach it. And I suppose it just highlighted to me that there must be all over the place links like that actually I can find, I can identify how I can then teach it and explicitly sort of show those links, and then work out how to use a common language, for example, with expanding and factorizing, common methods, so that I'm not overloading pupils, that I'm building on existing knowledge and connecting those concepts. That's where it is, and that's my example where I feel I've achieved something on that, and now I need to find plenty more of those. Go on. What about you? Have you got one?
I'm gonna say surds don't sit in my head, and there's some rules around them that I just don't seem to quite get. It would take me a day to plan a lesson to be really practical, but if I want to give more information about where that was going and across the curriculum, I would need a few conversations with my expert colleagues. Because, again, thinking back to 15-year-old Jen and not seeing it as just a topic that we're covering, I would want to be able to give my students more, not because of my own need for development. So that's where I really sit with that. Does that make sense?
Yeah, some topics lend themselves to practical experiments and real-world applications, and this is definitely a more tricky one. I agree. Yeah, but I think the benefit, and I think you're right, some of these areas will take us some really kind of heavy lifting to get to a good place at first. But once we've done that once and got it really clear, I think, as teachers in your mind, and how you're going to approach it, how you're going to teach it, and making sure you're really comfortable with the underlying maths, I think that's where we should hopefully only have to go through that once for each of these topics. So it feels like once you've done certs, that'll be it.
Yeah.
Then Jen can teach certs.
Yeah. And 15-year-old Jen will understand that.
Yeah. 15-year-old Jen in your school is going to be very happy.
Yeah. Because, I mean, I'm an employed teacher.
That's absurd.
Oh, buddy, you're too quick for me. I've literally had the longest day. So, on that note, should we sign off?
Well done. Awesome work on the job. Thanks. Always lovely to chat. See you again next week.
I'll see you again next week. Bye, everyone.
Thanks, everyone. Bye-bye.
Bye.
Thank you for listening to Fraction of a Teacher. If you've enjoyed this episode, please subscribe, leave us a review, and share it with your fellow teachers or friends. New episodes released every Thursday morning at 5 o'clock.
Follow us on Instagram or TikTok at Fraction of a Teacher Podcast for updates, behind the scenes fun, and more content. We would love for you to get in contact with us with your ideas, any questions you have, or things you'd like us to cover. So please email us at fractionoat@gmail.com or message us on social media. Until next time, keep smiling.
And keep solving those problems.